This video is Dilations, Day 2, 8.4 in your textbook on page 90. So you have learned that dilations preserve the shape of a figure, but change the figure's size. The size can be reduced or enlarged depending on the scale factor k. Each length of the image is k times that of the original figure. If the absolute value of the scale factor k is greater than 1, then the image is larger than the original figure. If the absolute value of the scale factor k is between 0 and 1, the image is smaller than the original figure. So if your k, for instance, is negative 1/2, or if it's positive 1/2, my image is going to be reduced from my original figure. That's what that's telling you. So let's talk about this think math. If the scale factor of a dilation is k equals 1, how does the size of the image compare with that of the object? Well, when you multiply by 1, you get the same. So their size is the same. Right? When you multiply by 1, you get that identical thing. It's called the identity. Their size is the same. Multiplying by 1, the identity. Let's go to the first example here. And yes, this is in your textbook on page 91. Triangle ABC is mapped onto A prime, B prime, C prime by a dilation with a scale factor of 3. So it says first draw a line from O to A, then extend the length of the line 3 times to point A prime. You find points B prime and C prime in the same way. Well, okay, from O to A, that's 1 unit long, and from O to A prime, 1, 2, that would be 3 units long because A is 1, 1, and when I multiply my coordinates by 3, I should get A prime at I should get that its coordinates at 3, 3, which is exactly what happened here. So multiplying by 3 is one way how I could figure out where the dilation is going to end up. However, caution, 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 only if the center of the dilation is at the origin can you then multiply the coordinates of the original figure by that scale factor to find the coordinates of the image. When using a different center, which you're going to see us do, you may want to draw the image to find its coordinates, not do the multiply rule. Part B, also in your textbook on page 92. ABC is now mapped onto A double prime, B double prime, C double prime, the second image, by a dilation with a scale factor of -1. So it's done here for us. In A, the scale factor was positive, and our triangle went up here, right? It was blue. And in B, the scale factor is negative, so the two image triangles, this for instance was A prime, are on the opposite sides of the center of dilation O. So a positive scale factor put it further into the first quadrant, but a negative scale factor drops it down into the third quadrant on a different side. So this one's below and this one went above. That's what that little information here was saying. This is not on your paper, but think about it. What is another transformation that will map ABC onto triangle A prime, B prime, C prime? The primes are not on your paper, and I don't even think this question's on there, but how else could I get ABC down to its image? Oh, I could rotate it. I could rotate it 180 degrees. Do you see that? Hopefully you see that because we've done rotation. Okay, let's go on to the next example. It says, Timothy uses a lens to view a 2-inch pencil that is represented by the segment AB on the coordinate plane. AB is mapped onto A prime B prime by a dilation with the center at the origin, O. Draw each image for the given scale factor. So I am going to, since it's the center is O, I'm going to multiply A's coordinates, which are 3, 2, both by -1/2. So -1/2 of 3 would be -1.5, and -1/2 of 2 would be -1. And then B's original point is 3, 0, and B's image would be -1/2, 3 times -1/2, and then 0 times -1/2, it's going to be 0. So this is B's image, this is A's image. So -1.5, -1, it's about right there. That's A's image. And B's image is -1.5, 0. So I can see that the A to A, this is another way that you can find the center of dilation. If you connect A with its image, with a line, a straight edge, and B with its image, where do they cross? At the origin. So yes, my center of rotation ended up being at the origin. So my new AB, which I'm drawing here, A prime, B prime, is over there in the third quadrant and on the x-axis. So now it has part B says it has a scale factor of 1/2. So A, which was originally 3, 2, when I multiply it by +1/2, I'm going to get 3, 2, I'm going to get 1.5, 1. And B's image, when I multiply 3, 0, I'm going to get, these aren't the same point. Silly me. A's original point is 2, 3. I thought they were using the same point as over here. A's original is 2, 3. So now times 1/2, that's going to be 1, 1.5. So they switched the x and the y here. So that's A's image. And B, the original point is 2, 1. So now taking half of those, it's going to be 1 and 1/2 is B's image. So A goes to 1, 1.5. And B goes to 1 and 1/2. So here's A's image, A prime, and here's B prime. This board is so long. And if I connect with that line idea, if I connect A to its image and B to its image, where would they cross if I connected those lines? Trying to go over that line again, which is not going to happen with this board. But where they would cross is right here at the center of dilation, which is the origin. So that's coming up. We're going to find the center of origin or the center of dilation. The origin is the center of dilation, where the point and its image cross. How to find that? That's that extra worksheet that I talked about. So here it is, page 93 in the textbook. So you have learned how to find the scale factor of a dilation from a figure and its image. You can also find the center of dilation from the same information. If two figures related by a dilation, suppose you are given 2 points A and B for their figure and their images A and B. Use these steps to find the center of dilation. Draw a line through A and A's image. Draw another line through B and B's image. Find where those two lines intersect. This is the center of dilation. the following examples that maps AB, the red that you see here, onto its image, the blue, by a dilation illustrates this, a dilation in which K was greater than 0. So my AB got larger. Now my A prime, it's now A prime, B prime. And if you connect those lines, which you see are dotted, you can see that the center of dilation, where those would cross, is right here at 2, 0. Let's look at another one. What happens when K is less than 0? Also still on page 93. So my original image is AB, this red one, and the intersection of those lines, A connected to its image here that you see dotted, and B connected to its image dotted, is also at 2, 0. So the center of dilation is 2, 0. See where these lines crossed? The magnitude of the scale factor, so the size of the scale factor, can be found by either of the following. The scale factor's magnitude is equal to the distance from the center of dilation to the image, the center of dilation to the image. So, for instance, 2, 0 down to 4, -2, this distance, which would be 2 units away, over the distance from the center of dilation to the original point, that's only 1. The other way you could do it is the length of the image's segment. Okay, well, segment A, the image's segment, B to A, this blue here, and A to B, the original segment, is only 1 unit long, so 1 unit on the graph paper, compared to this 2 units. So I can see that the image A prime, B prime is twice as big. The scale factor of a dilation depends not only on its magnitude, but also on whether it is positive or negative. That is, whether the image of each point is on the same side of the center as the original point or not. Okay, so same side of the center. Here's the center. So A is above, but A's image is below. B is above, but B's image is below, because I have a negative scale factor here. It's -2, by the way. On the example before this, here's the center of dilation. Both A and A's image are both above the center of dilation. B and B's image are both above. This is a scale factor of +2. When it's a negative scale factor, do you see how A and its image are on opposite sides of the center of dilation right here at 2, 0? So that's what this little math note is talking about. Here's another example that's done in the textbook on page 94. The table shows the coordinates for this triangle. So the original triangle here is in red, A, B, and C. It says, draw each triangle and its image on the coordinate plane, then mark and label P as the center of dilation, which you can see is down here. It's at -2, -3. Find the scale factor for each triangle, then describe the transformation. So A is joined to A prime, B is joined to B prime. Both of those lines intersect at the center of dilation, which is -2, -3, which we see in the map there. They did this one for you. The scale factor, so the image of AB, which is in the blue here, is 2 units. So that's this 2 right here. The original image length is from A to B here is 4 units. So 2/4 equals 1/2. So ABC is mapped onto A prime, B prime, C prime by a dilation with center P at -2, -3, and a positive scale factor. How do I know it's positive? Because the image and its original are both above the center of dilation, so it's a positive 1/2. You can also join C to C prime if you want to find the point of intersection with another line to locate the center of dilation. But 2 lines, when they cross, that's, yes, I could also here draw in C to C prime and show you that, C to C prime, as I'm going through C prime, if I keep extending it, yep, I'm going to go through that center of dilation as well. Another example, because we're going to do one in class. D, the original triangle is DEF in red, and it's mapped onto D prime, E prime, F prime in blue. Now they're on opposite sides of the center of dilation, so I know it's going to be a negative scale factor, number 1. And if I connect F to F prime and D to D prime, and I could also connect E to E prime, right? And you can see that it would also go through that center of dilation point P, which is 1, 3. And the scale factor, the image, which is in blue here, is 2 units long. And the original is 4 units long. So 2/4 will give me a scale factor of 1/2. And why is it negative? Because they are on opposite sides of the center of dilation. So we're going to try this. Number 9 here. Not in your textbook. This is in the extra practice page, I believe, from the textbook. So we have to draw the triangles and map it onto its image. And it says, O as the center of dilation, find the scale factor for each figure. No, O is not the, mark and label O as the center of dilation. No, O is not the center of dilation. That's wrong. I don't know why it says this here. But we're going to find the center of dilation, so cross that off. Find the scale factor for each figure. Use one grid on both axes to represent. Okay. So A is 0, 4. 1, 2, 3, 4. So here's A. B, so this is the original triangle, is 3, 4. And C is 3, 1. So this is the original. I'm going to connect them using a straight edge. Those of you that don't use a ruler, please use a ruler. Whoop, it's off a little bit. Okay, then is mapped onto 0, -6. So I'm going to draw that one in a different color. So 0, -6. 1, 2, 6. So here's A's image. B is -2, -6. And C is -2, -4. So it definitely got smaller. So I have a scale factor that's less than 0. So I'm going to connect this triangle's sides using a straight edge or a ruler, please. And now I'm going to connect A to A, B to B, and C to C using a dotted line. So A to A, well, that's just the y-axis, so I don't need to connect that. C to C's image. B to B's image. And yes, A to A's image would just be right down the y-axis here. And we can see that the center of dilation here, they're all intersecting here at 0, -2. So the center of dilation is 0, -2. And the scale factor, okay, so the image, which is 2, so I'm going to say side AB. Side AB is 2 units long, and side AB of the original is 3 units long. And I know it's going to be negative, a negative scale factor, which I can call K, or I could write scale factor. I could write out the words scale factor. That's what K is. It is the scale factor. The scale factor is -2, 3 with a center at 0, -2. So let's do the next one, last one. So we have this square I think it's going to make. W is 1, -1. And X is 2, -1. Oh, a tiny little square here. And Y is 2, -2. And Z is 1, -2. So my original little square here. And I'm mapping it onto W, which is -3, 5. 1, 2, 3, 4, 5. And X is 0, 5. And Y's image is 0, 2. So it definitely enlarged. And Z's image is -3, 2. Carefully using the lines of the graph paper here. Should be using a straight edge. Okay, so my image and its original. So my center, let's connect a couple of these points here. And I'm going to use a dotted line here. Let's connect Y to Y and maybe W to W, W prime to W. I'm going to have to continue this because they're not intersecting so far. I have to do this again. And just for the heck of it, I'm going to do X to X's image and see if they oh, yep, they're going to intersect right there. I can see that. So they're going to intersect right here at 3, -4. So the center of dilation is 3, -4, not the origin. And the scale factor, K, the image is 3, a length of 3 units. And they're both above my center of dilation. So this is going to be a positive scale factor. And WX, the original, is only 1 unit in length. So K equals +3/1. So it's a scale factor of 3 with center at 3, -4. We're going to practice some of this in class tomorrow.